Well, pumped to be here, everyone. Thanks a ton for tuning into the talk. We're going to talk about how Airflow and Yugabyte can be used together to kind of create standard patterns for organizations to use.
Yeah, welcome everyone. Excited to dig in here and excited to do this talk, even in this distributed world. So I hope this recording does its job, and hopefully we can be there and answer Q&A even retroactively. So for starters, we want to do a quick introduction of ourselves. I'm Pete DeJoy. I work on ecosystem products here at Astronomer.
And I'm Raj Parak, and I lead our field engineering team.
Cool. So let's start by talking about Airflow just a little bit. Airflow is what we're all about over at Astronomer. If you're not familiar with Airflow, it's an open source tool to programmatically author, schedule, and monitor data pipelines in Python. It has become a very, very popular framework for orchestrating workflows and data pipelines in the modern open source data stack. It was born inside Airflow in 2015. It graduated to a top-level Apache project in 2019. And today it has 20,000 plus GitHub stars, 600,000 plus downloads a month on PyPy, and 1,000 plus enterprise teams running Airflow in production. Astronomer has been fully focused on Airflow since 2018. We're building a commercial business around it, and we've had a lot of fun digging into the project.
Yeah, so a little bit more about Astronomer here. In the same way Databricks is to Spark and Confluent is to Kafka, you can think of Astronomer to Airflow. So we're really helping organizations of all types across all stacks and clouds and use cases adopt Apache Airflow to put their data in motion.
Yeah, and we at Astronomer are big fans of distributed databases generally, right? Like we have customers running across the world in globally distributed setups that need to be fault tolerant and highly available. We're a big fan of the work that the folks at Yugabyte are doing around making highly available distributed relational databases. And, we definitely see a major use case for it in the context of our enterprise customers. And at a lower level, Airflow loves the data ecosystem. One of the great things about Airflow generally is that it has a really rich ecosystem of open source connectors, standard patterns for abstraction for loading and connecting to data stores, doing all sorts of transformation, analysis, things of that nature. So one of the great things, again, is that Airflow has a really robust community, and a lot of folks have put a lot of time and effort into building out standard templates for doing data processing. That's what we're going to be chatting a little bit more about today. So to give a quick overview of how pipelining works in Airflow generally, right? Like as we said before, all pipelines in Airflow are defined by some templated Python code. That means that it's quite flexible. You can write and define whatever logic that you need to have defined in order to process your data pipelines. Everything in Airflow is defined as a DAG, or a directed acyclic graph. If you're not familiar with the DAG concept, this is a nice little visualization here. Basically, what it really is an interdependent, visualization of nodes, right? Like with upstream and downstream dependencies, and there can't be any circular logic. So the nodes can't be self-referential and can't reference, upstream tasks. So what you get is a really nice abstraction layer on top of your logic that makes for easy monitoring, easy retries, easy, downstream failures. And that's, at the core of what Airflow does very, very well. And we'll walk through a contextual example of this in a bit. Talking a little bit more about the Airflow ecosystem that I had touched on prior, Airflow is really built up of a couple of core fundamental concepts and building blocks that make it really, really easy to author and deploy these pipelines. There are things called hooks, which establish connection to third-party data stores like Postgres or Yugabyte. And then there are things called operators, which perform some set of predefined logic tailored to specific use cases. You can think of both of these as just Pythonic abstractions over third-party APIs that accommodate some sort of use case. In Airflow specifically, there are action operators, transfer operators, and sensor operators. Actions, again, perform some set of arbitrarily defined logic. Transfers take care of moving data from point A to point B in a pre-canned way. And sensors wait for some sort of external trigger before launching some sort of logic. So that really allows you to fit Airflow to an event-based paradigm if that's something that you're looking to do. And all of these modules are bundled up into a higher level of abstraction called providers. So what providers are just Python packages that contain all relevant modules for a specific service provider. So if you are a big AWS shop and you want to use Airflow to interact with AWS services, you can pip install the Airflow AWS provider package, and you have access to all of the underlying submodules, hooks, operators that allow you to interface with AWS services directly from your DAG files. And the providers framework is super valuable, and it actually just kind of underwent a pretty major change with the Airflow 2.0 release. Again, these providers are just abstractions that allow you to interface with any third-party service provider, database, data tool, data system, and connect, transfer, manipulate, analyze data living in those systems. Airflow 2.0 was a major milestone for the community, and it was released in December, which included a whole bunch of features. But one of the great ones for the ecosystem and for the community at large is that the providers were actually decoupled from the core Airflow project. So we have really a complete sense of plugin freedom, right? Like we can develop, release, maintain these operators and provider modules independently of the core project, such that we can continue to build at a faster pace and version these abstraction layers above third-party APIs independently of the core Airflow services, which makes for a very nice user experience when it comes to actually developing these integration layers, right? So we're really excited about this, and we're really excited for what's to come here.
So when you think about what these providers really unlock for organizations, is really the idea of being able to express their data pipelines as code. This is a diagram that one of our customers used to kind of represent their data flow, where Airflow is really the tool that's coordinating data between their legacy stack using tools like Teradata and Oracle, and their 2.0 stack, which is all in on Azure. The nice part about all of this defined as code is that when a new business requirement comes along, suppose you have to take a new business survey somewhere, you can really take that and expand on it relatively easily. So, in this case, where now I have to kick off a new business initiative that's taking data from a Kafka stream, I can do that with some pre-canned code that really makes all my data teams a lot more productive. So, diving into a real-world example here, we're going to do a little bit of a hypothetical situation. I'm a data platform engineer, and in this example, Pete's a data engineer. And we have this use case where we're going to have a lot of users that are going to be moving data from an application database on MySQL over into Yugabyte Cloud, which we're kind of using as our next-gen database. So you can really think of this task as three major steps, where you need to connect to MySQL, extract the data, and load into Yugabyte.
Yeah, so just to expand upon that, right? Like I, as the data engineer in this situation, would be responsible for figuring out the best way to do each one of these steps. And, we can dig into what that looks like here in the context of the Airflow ecosystem. So if I'm trying to connect to MySQL, right, like there are a couple different ways you can do that. Because Airflow is fully Pythonic, you can build your own custom connection module. But as a data engineer, I like finding pre-canned code that's easy to use and I can just plug and play. So after Googling around a little bit, I discovered that there exists an Airflow MySQL hook that allows me to easily connect to my MySQL instance. It's open source, it's available in the ecosystem, and it's well documented. So that makes my life very easy, and it makes Viraj happy. Expanding upon that a little bit, the next step would be for me to figure out how to actually extract that data from my MySQL instance that I've connected to and loading it to S3. Again, I want to see if there are good examples out there, good pre-canned templates that I can leverage. And after Googling around a little bit more, it turns out that there does exist an Airflow MySQL to S3 operator in the open source that makes it very easy to just perform basic, extract and load from MySQL to an S3 bucket.
So then from a data platforms engineer's perspective, I love this because this is so much more maintainable than every one of my developers finding out a way to do this on their own.
Then you talk about loading to Yugabyte Cloud, right? Like I'm looking around and I'm Googling my way to victory over here, but I don't see a Yugabyte provider or Yugabyte operator in the ecosystem at the moment. So then, you talk about a couple different things that could happen, right? Like as Viraj mentioned, all of our engineers, myself included, could go and try to build our own custom logic for loading to Yugabyte Cloud using their API. But there's actually a cleaner way to do this. I see that Yugabyte, when I'm doing my research, I see that Yugabyte is Postgres compatible, which is really nice, right? Like I get the expected experience and a known experience from working with a Postgres instance or a Postgres compatible database instance. I see that Airflow has a pre-canned Postgres hook. So, there already has been a good bit of work done in the community on connecting to Postgres databases. And I also see that Airflow has an S3 hook, which makes it really easy to plug into any sort of S3 instance.
So given Airflow's already done all this work for me by leveraging kind of the huge community of users around Airflow, this makes it really easy for myself, the data platform engineer, and Pete, the data engineer, to collaborate, try to figure out a scalable solution that works for several members of the team, but also is easy to maintain and extend upon as my business requirements change. So I'm going to jump into a quick demo here and just kind of show you what this looks like in practice. So on one side here, I have my Yugabyte cloud cluster pulled up that's ready to push data into. And I have a terminal interface on my other side. So to start off here, I'm running the Astronomer CLI on this machine. This is part of the Astronomer packaging, but it's also an Apache 2 licensed open source tool that's just meant to be the easiest way to run Airflow on your laptops. So to get started, I'm going to do an Astro dev start here. And this will kind of in the blink of an eye build me a developer environment for Airflow, so I can start actually iterating on my DAGs and iterating on my operators that I'm working on with Pete here. So while this gets spun up, I'm going to open up my code editor, like using Visual Code, and kind of dive right on it. Alrighty. So then once this is ready, I'm going to pop the localhost to 8080. It gets a few seconds to get spun up here. Taking a little longer than it usually does. There we go. And just log in with my default creds. Awesome. Oh, shoot. Cool. So then now I have a couple of DAGs here. And what I want to walk through really is just how you can use these incrementally to build up your use case. So let's dive into my code. Let's go into my first tag, my MySQL to S3 operator. Go to the graph view here. Let's look at this code. So using there we go. Using a pre-built Airflow connector, what I can do is I can just import this connection as a Python module and just fill this out as if it was a configuration file that tells me where my data is going to go in S3, where my MySQL connection is, and what query I want to run to extract this data in. This is really helpful from a data platform perspective because now my users are all going to be iterating on this workflow in a standard way. So I'm going to define my tables here, loop through my sets of tables, and all of a sudden I have a couple of tasks here that show me how I can take my data from MySQL and move it into S3. Going to the next step here, let's look at my MySQL to Yugabyte workflow. So let's pull up the code here, kind of go through. Oh, wrong one. So the first half of my workflow is the same, where all I'm doing is taking my pre-built Python, my Python abstraction, and importing it. So I have my MySQL parts. The next part of my workflow is where the Yugabyte piece comes in, where what I'm doing is using something called a Python operator in Airflow, which is just a way to run an arbitrary Python function inside of Airflow. So I define my logic right here in this little Python function where I'm instantiating connection to S3 and my one to Yugabyte, and using pandas to do my load and transform layer. And I'm looping through my tables. If I expand on Yugabyte here, you can see that I now have a workflow for each of my Yugabyte pieces. The issue with this approach is that this little Python script isn't very scalable. This might work for just Pete's use case, but what if we have some other workflow, some other users that want to be doing these extracts and loads and these transfers? Or what if I have a specific business requirement where I don't want certain tables to be moved over? This approach is really powerful and lets you get the job done quickly, but it leaves a lot of room for error from the developer. So that's where we can enter a custom operator that I'm writing as a data platform engineer with input from what my data engineer needs to do. Pop over here, go into my operator, just jump into my graph view here. So you can see the graph of this is exactly the same, where I'm still performing the same logic, where I'm taking my data from MySQL and loading it into Yugabyte. But from a code perspective, it's a world of difference. So let me pull up my code here, where the first part of my code is still the same. But as far as the second part of my code, my S3 to Yugabyte phase, I've actually written a custom operator in my plugins section, where just like my MySQL part, all I have to do is give my users a template to fill out to say like, hey, where is the Yugabyte connection? What kind of load do I want to do to this data? What's the table's name going to be? And then just kind of giving users that template allows me to start having a maintainable, scalable way for my data team to start taking data from that MySQL instance I have and loading it to Yugabyte in a way that makes sense for them. And Yugabyte Cloud makes this really easy as well, because I can just give them a database in Yugabyte Cloud. And since it's just Postgres compatible, my users are already really familiar with how that works under the hood. And Airflow gives you a bunch of information about how this workflow ran over time and metadata and so on that my users can use to really iterate on optimizing this workload. That said, I'm going to stop my share here and pump it back to Pete for the last slide.
Sure. Yeah. Yeah. I think like one of the things that we really wanted to highlight here is it is quite easy to build these custom operators in Airflow that are, sorry, I'm trying to figure out how to present here. There we go. That are pre-canned that you can deliver to your data engineers as a platform engineer, and just give them the parameters, the documentation, what they need to pass as arguments to that pre-canned operator, so that you have standard expected patterns for these data loading functions, right? Which makes it very, very easy to scale across multiple teams and many, many engineers writing data pipelines. So to take that one step further, right? Like, actually, Viraj, I'll let you do the honor.
Yeah. So kind of taking it all the way, as data platform engineers and data engineers collaborate, they can use Airflow's provider and operator framework to take scripts and one-off ways of doing business critical things and rewriting them into maintainable, reusable, and extendable operators that can be leveraged across different use cases within the organization.
Yeah, and just like taking it one step further, right? Like with this new provider framework that's been released in 2.0, we're observing a bit of a paradigm shift in which a lot of these, at least this provider development, right, like is standardized such that these operators are added to standard open source Python packages as submodules, right? Like all of this is part of an open source ecosystem. So all of the source is just living in, repos owned across GitHub. And then they're delivered as standard Python packages that any user can access, understand, and plug into their data flows. So that allows you to do is really leverage some of the work that other teams have done as well in the ecosystem and community to continue to develop on some of those standard loading patterns and practices. So we're really excited about what's to come as we kind of move forward towards Airflow 3.0, and look forward to seeing what folks do building and distributing these custom operators. You can learn more about Airflow 2.0 and Astronomer and Airflow at large at astronomer.io/Airflow. We have a nice, easy guide on how to get started with it, how to run it on your local machine using the Astro CLI that Viraj just showed off. So happy to include this in the session notes or wherever they're easily accessible. Obviously reach out to us personally. I'm just Pete at astronomer.io. Viraj is Viraj at astronomer.io. We would love to chat and love to help you try this out.